Okay, today we're doing lesson 4.15, so module 4, lesson 15, and we've kind of been moving in baby steps, right? Do you guys remember our learning goal from Monday was use a rectangular fractional model to multiply what times what? Yeah, unit fraction times unit fraction. And then yesterday we did unit fraction times non-unit fractions, and today our learning goal is I can use a rectangular fractional model and a multiplication sentence, so two different ways, to just multiply fractions. Doesn't matter anymore if it's a unit fraction or not. We just can multiply after today all different kinds of fractions. Does that make sense? Mm-hmm. Do you see how we're kind of taking baby steps to be able to multiply fractions? Yeah. Today we're going to use two different strategies. We're going to use a rectangular fraction model, which is what we've been doing, but we're also going to extend it to also just use multiplication sentences. Make sense? Mm-hmm. Cool. Let's first talk about the problem of the day. So once again, the problem we're trying to solve is 2/3 times 3/4. And we have two different ways, two different strategies that we need to be able to do it. So let's first talk about how we can use a rectangular fraction model. You can see that I started drawing a rectangle and I labeled the whole thing as 1. Right? And then I sectioned off 3/4 and I labeled it. And I colored that in black. Right? I colored it 3/4 of my whole rectangle. But I didn't want all 3/4. I only wanted a fraction of it. What fraction of it did I want? 2/3. So then I split it into thirds, and I colored in 2/3, and I made sure to label it. So now all I need to do is I need to look at how many different sections have two colors. 1, 2, 3, 4, 5, 6. Huh? Out of a total of how many? 6/12. And can I simplify that? What does that equal?
1/2.
1/2. So I think my answer, 2/3 of 3/4 is going to be 1/2. Okay? But let's try using multiplication first. Now we know that 2/3 of 3/4. How can I write that as a multiplication equation? How can I write that as a multiplication equation? Lakshan?
2/3 times 3/4.
You got it. 2/3 times 3/4. Okay. Now, we saw that we can put the numerators together and the denominators together, and we can multiply them. So what we can write is we can write that this equals 2 times 3 over 3 times 4. Right? Did we already prove that that's true?
Yes.
Now, right here in my thought bubble, how can we use what we know about similar factors in the numerator and denominator to help us simplify before we even multiply? Remember, when we have similar factors in the top and bottom, they can cancel each other out. Sometimes people call that cross-cancellation. Do we see any similar factors? Yeah. What number do you guys see that's both in the numerator and the denominator? 3, which means I can basically cross them out. I can divide them both by 3, and if I do 3 divided by 3, what do I get?
1.
And if I do 3 divided by 3 down here, what do I get?
1.
Do we see any other similar factors? Danielle? 1 and 1 are the same, but we already dealt with that. 1 is nice because we know the identity property of multiplication means that we can almost ignore the 1, right? Anything else, Drew?
2 and 4.
Ooh, 2 and 4 are both divisible by what number?
2.
2. So I can do 2 divided by 2, which is?
1.
And I could do 4 divided by 2, which is?
2.
Okay, so now my new problem is 1 times 1 over 1 times 2. 1 times 1 is?
1.
And 1 times 2 is?
2.
Did we get the same answer both ways?
Yes.
Nice. Now, when we have this problem, 3/10 times 5/9, we have to think to ourselves, does it make more sense to draw a rectangular fraction model? Or does it make more sense just to do multiplication and why? Talk to your table group. I heard you guys have really good discussions about whether a rectangular model is better or a multiplication equation is better. Jack, what did your group decide?
We thought multiplication because if we're doing the model, then we're gonna have to draw a lot of lines.
Yeah, you have to split it. If I draw a rectangular model and I want to show 3/10, I have to split it into how many equal sections?
90.
10 first, and then 9 the other way. 90 sections. Is that a lot?
Yeah.
Is it impossible? No, but is it a good idea? No. Not really. So in this case, when the numbers are big, it might be a good idea just to write a multiplication equation. So what would be my multiplication equation in my numerator? Everyone?
3 times 5.
And what would be in my denominator?
10 times 5.
Ooh, we have some big numbers. Especially when we have big numbers, I like to look for similar factors so that we can cross-cancel, we can simplify before we even multiply. Because it's not that we can't multiply big numbers, it's just that it's easy to be imprecise when we do that, right? And also, a lot of times we forget to simplify our fractions. So if you simplify before you multiply, you have a better shot at having simplest form. So do we see any common factors? Remember, what you can do is you can just look, or you can write the prime factors of all the numbers. Okay, but let's just look. Do we see any common factors? Lauren?
5 and 10.
Ooh, 5 and 10 are both multiples of 5. So what's 10 divided by 5?
2.
And what's 5 divided by 5?
1.
Careful.
Yeah.
Okay. Anything else? A DT?
3 and 9.
Ooh, 3 and 9 are both multiples of 3. So 3 divided by 3 is? And 9 divided by 3 is?
3.
Now my new problem. Sometimes after I cancel it and cross things out, I like to rewrite the problem because do you guys see how it can be a little sloppy and I can make careless mistakes this way? So I like to write it out. So I have 1 times 1 now over 2 times 3. There's nothing else I see. Okay, so 1 times 1 is?
1.
And 2 times 3 is?
6.
So my answer is? 1/6. I need to look back at the problem. Did I actually answer the question? Yes, because there's no word problem or anything like that.